Now, one of the main reasons why we perform correlation is so we can perform linear regression. So here is some data that I've been working with for the last 2 lectures, and we calculated a Pearson's R. We found the correlation to be 0.99. So that 0.99 means that there is a very strong relationship. So if we know that 2 variables are strongly correlated, we can use one variable to predict the other variable, using this equation right here, where y hat is the variable we're attempting to predict, and we're going to predict that with x with the slope, which is beta 1, and the y-intercept, which is beta 0. So we're going to put in an x and find y. In order to do that, we need to find out what beta 1 and beta 0 are first, using these 2 equations right here. So the stronger your correlation, that is, a closer R is to -1 or 1, the more accurate your prediction will be. Our R is 0.99, so we can expect our prediction to be pretty accurate. So let's get started with that. First, we need to find B1. Remember that our R is 0.99, so we can just put that in there. Now we need to find S of y and S of x. So here's our data set with the x and the y. And I'm sure you remember how to find standard deviation, right? We're just going to use this equation to find the standard deviation of x, where we find the sum of all x squared, which is every individual value squared and then added together. And we're going to find the sum of all x squared, which is every value added together and then squared. So we've got 15,629 and 136,161. And we can put those things into the equation, as well as n, which is 10, that's obvious. And solving for that whole thing, we get an S of x, a standard deviation of x, of 14.96. So we put that in there. And now we're going to do y the same exact way, just now it's y instead of x. So we're going to find the sum of all y squared by taking each individual y, squaring them, and adding them together. And then we're going to find the sum of all y squared by adding together all the y's and then squaring them. And we're going to get those 2 huge values. So we're going to put those in the equation. We're going to put in 10 for n, and we're going to find the standard deviation of y, which is 19,902.26. So now we can put that into the B1 equation and find a B1 of 1,317.06. Now we found B1 first because you need B1 in order to find B0. So we need to find the mean of y and the mean of x. Remember that the mean is just you add together all the values and then divide by however many values you have. So the mean for y is 42,100 and the mean for x is 36.9. So just plugging in those 3 things we already know into the beta 0 equation, we find a beta 0 of negative 6,499.51. Now going back to this original equation, we can replace the 2 betas, which we now know. So we get an equation that looks something like this, where our predicted y is equal to 1,317.06x minus 6,499.51. We did this because using this equation, we can plug in any x we want and then solve for y, and that's what we would predict y to be. So for example, let's predict the yearly income of someone who is 33 years old. We just put in 33, and we get a yearly income of 36,963.47. So you can go back to the data table that we had and look, how good was our prediction? For people who are about 33 years old, about how much money do they make? Is our prediction good or bad? This one overestimates it a bit because I only rounded to 2 decimal points, so it's not exactly perfect, but this is still a very good prediction. So we can use our x values to predict values of y in linear regression.